Hello students, today is the third part of Chatelier principle. So today we will study the effect of change of pressure on equilibrium. That is effect of change of pressure on equilibrium. So let me repeat once again that word change means either increase or decrease. So how the increase or decrease in pressure will affect the state of equilibrium in a reaction, and the state of equilibrium effect on the state of the equilibrium will be manifested in the concentration of either reactants or products. Or I mean to say, when we will change the pressure of a reaction which is in equilibrium, either the concentration of the reactants will increase or concentration of the products will increase. ठीक है, or other vice versa, that concentration of reactant will increase or pressure and concentration of the products will decrease, or the concentration of products will increase and concentration of the reactants will increase. So let me give you an example. N2O4 will converting into NO2, 2 moles of nitrogen dioxide. ठीक है, dinitrogen tetroxide is converting into nitrogen dioxide and giving 2 moles of nitrogen dioxide, and both reactant and products are in gaseous state. Here 1 mole and here are 2 moles. So let me tell you first condition, that which reaction will be affected by the change in the pressure. So only those reactions will be affected in which reactant and products are gaseous. Only those reactions in which reactant and products are in gaseous state. So keep it in mind always. So next is the see this reaction here, forward reaction is happening with formation of 2 moles, whereas in case of backward reaction there is only 1 mole. Reactant has 1 mole and products have 2 moles. So if now the pressure on the system is increased, the equilibrium will shift to the side in which pressure decreases, that is to the side which is accompanied by decrease in the number of moles. So let me tell you, if there is a container in which total 3 moles are present, that is this reaction is in equilibrium, and here 1 mole of N2O4 and 2 moles of NO2 are present. Total there are 3 moles. Is that clear? So there is a certain pressure at which these 3 moles are coexisting at equilibrium, and if now I will increase the pressure, here, so it is clear that with the increase in the pressure this volume is decreasing. Is that clear? So earlier there were 3 moles in this particular volume. Now the volume has been decreased and 3 moles are so 3 moles will adjust themselves to the volume so that their ratio remains same as earlier. So increase in the pressure will shift the equilibrium in that direction in which there are lesser number of moles. Is that clear? Increase in pressure will shift the equilibrium in that direction in which there are lesser number of the moles. Increase in the pressure and equilibrium will be shifted in direction where lesser number of moles or decrease in the number of moles. So when we will increase pressure, in this case the equilibrium will be shifted in the backward direction. Okay, and when we will decrease the pressure, the equilibrium will shift in the forward direction, because I told you earlier here that there is the number of moles in particular volume are present, and when we will change the pressure, either we will increase or decrease the pressure, there will be number of moles to the volume tends to be remain practically constant. So there are many more examples, like you have to solve them yourself, like this example. N2 plus H2 is giving us NH3, that is ammonia. Yesterday we did this reaction for the sake of temperature. All are in gaseous state. So there are total 3 plus 4 number of moles here, and there are 2 number of moles. So how will change in the pressure will affect this equilibrium? You have to solve yourself. So there are many more examples, so you can take them. So now I am writing some examples. First of all, this example, ammonia. Here delta H is, value of delta H is 92.4 kilojoule. So here you have to solve that what will the effect in the change in the temperature, pressure and concentration. What will the effect of change in the temperature, that is increase. First of all, if we will increase the temperature, what will the effect on the equilibrium concentration of these reactants and products, and then if we will decrease, what will be the effect. Same here, what will be the effect of change of the pressure and concentration. So you have to solve this yourself. Next is the nitric oxide, formation of nitric oxide from nitrogen, NO. So value of here delta H is, delta H value will be used to determine the effect of change of the temperature. Keep it in always mind. If you have to know the change in the pressure, how the change in the pressure will affect the equilibrium concentration, then you must know the number of moles on reactant side and product side. Okay, then increase in the pressure will lead to the equilibrium to the lesser number of moles, this way. Okay, and in case of temperature, you must know whether reaction is the endothermic or exothermic, and you will came to know from this enthalpy change data that whether reaction is endothermic or exothermic. For the increase in the temperature, if we will increase the temperature of an endothermic reaction, equilibrium will shift in the forward direction. And last is the concentration. So concentration, I also effect of the concentration is very simple. If you will add the reactant, the concentration of product will subsequently increase. If you will add the product, the concentration of the reactants will increase. So it's very easy to remember, and if you want to understand it more, solve more and more examples. That will keep your concept clear. Okay, so this was the Chatelier principle. Okay, if you have any problem, you can discuss with me. Okay, thank you.